All right, before we start, someone to please let me know if I'm audible enough. Currently, I'm loading the file that I'm going to be using in this live class. Before we get started, I want you to confirm if I'm audible enough. Otherwise, good evening, my excellent students. Hope you are doing fine. Hope you had a wonderful day. So, please let me know if I am audible enough. Right now, I'm currently uploading a file that I'm going to use in this live class. So it's still loading. Otherwise, okay, I am audible. Okay, wonderful. Okay, so in today's live class, I'll be answering mock paper one. I'll answer about 10 questions. In fact, we're going to answer the questions together. So I'll be answering and explaining. Okay, answering and explaining. So as I'll be answering these questions, I'll also be giving you tips on how to answer paper one questions. Okay. Otherwise, I'm just waiting for the file to upload so that I can display it. Okay, it has finished uploading. Okay. Okay. Then I'm Guatamba Bola. Only 5 people are watching. Where are the others? They are watching football. Where are the other students? I can only see 5. Now it's 9. Where are the other students? I announced that today we are having a live class. Vanda kuti vantu. Watamba bola y'abakazi. Okay, so please let me know if you can see what is on the screen right now. Good evening, Olipa. Good evening, Esa. Precious. Good evening. Much because of my background. If you can see what are we able to see what is on the screen? Are we able to see what is on the screen? Okay. Wonderful. So I think I can start. So this is the paper that I gave you last week, Saturday. We had this paper. This was our mock paper one. Okay. Yeah. So we're going to start with the first question without wasting much, of our time. So the first question reads: the diagram shows an animal cell. Let me just maybe zoom in a bit. So the question reads: the diagram shows an animal cell. The diagram shows an animal cell. So we've got that diagram there. We've got A, B, C, and D. Which structure, A, B, C, or D, controls the substances that enter or leave the cell? Comment your answers quickly. Comment your answers quickly, because we do not really have much time. Okay, I want us to do this as quickly as possible. So what is the answer for question one? The diagram shows an animal cell. That is our diagram there. It is an animal cell. We've got parts labeled A, B, C, and D. The question is asking us which structure, A, B, C, or D, controls the substances that enter or leave the cell. What is the answer, my excellent students? What is the answer for question one? What is the answer for question one? Answers right now. What is the answer for question one? Answers right now. Excellent. So the answer for question one is A, which is the cell membrane. Okay, the cell membrane is the structure which controls the substances that enter or leave the cell. Okay, A is the answer for question one. Cell membrane. It is selectively permeable, meaning it allows some substances to pass through it. Simple. Okay, let's go to question two. Okay, so question two reads: what is the main characteristic? What is the main characteristic feature of the red blood cell that helps it perform its function efficiently? What is the main characteristic feature of the red blood cell that helps it perform its function efficiently? Well, what you need to know is that red blood cells are the ones that are responsible for transporting oxygen. Red blood cells, that's what they do. They transport oxygen. So this question is asking us to identify a characteristic amongst the four options which enables red blood cells to perform that particular function, which is to transport oxygen. So we've got A, the round shape; B, the lack of a nucleus; C, the presence of hemoglobin; D, the biconcave disc. Okay. So what is the main characteristic feature of the red blood cell that helps it perform its function efficiently? So what do you think is the answer for question two? Question two. I want to see answers. I want to see answers. What do you think is the answer for question two? Okay. What is the main characteristic feature of the red blood cell that helps it perform its function efficiently? Okay, so the answer for question two is C, the presence of hemoglobin. What you need to know, my excellent students, is that all these, if you look at the options that we have, B, which is the lack of a nucleus, that is one of the characteristics of red blood cells. D, the biconcave shape, that is another characteristic of the red blood cells. But the main one, which is a main feature that enables red blood cells to carry out their function, is the presence of hemoglobin. Hemoglobin is just a protein that attracts oxygen. So as blood is passing through the lungs, this hemoglobin, it will attract that oxygen from the lungs. That is why red blood cells transport oxygen, because they contain hemoglobin, which attracts oxygen. So C is the answer for question 2. So let's look at question 3. Question 3 reads, two different concentrated sugar solutions are put in a beaker and are separated by a selectively permeable membrane as shown below. Two different concentrated sugar solutions are put in a beaker and are separated by a selectively permeable membrane as shown below. So that is our beaker, okay? And there's a selectively permeable membrane. I'm sure you can see it. This membrane here, there's a membrane here, okay? So we've got a beaker, we've got a selectively permeable membrane, and then on this one side of the beaker, we've got 10 grams sugar dissolved in 10 cubic centimeter of water. And then on this other side, we've got 5 grams dissolved in 10 cubic centimeters of water, okay? Or centimeters cubic, I mean. So on this side, we've got 10 grams of sugar dissolved in water. On this other side, we've got 5 grams of sugar dissolved in water, equal amount of water. And then there's a selectively permeable membrane, which is separating the two sides. Okay. So the question reads, which of the following beakers shows the correct end result of the experiment? Which of the following beakers shows the correct end result of the experiment? Is it A? Is it B? Is it C? Or is it D? What do you think is the answer for question 3, my excellent students? What is the answer for question 3? Okay, so some are saying B, some are saying C, some are saying D, some are saying A. Now, we need to understand what is happening here. Osmosis is taking place. That is what is happening here. Osmosis is taking place. Now, when you look at this situation, yeah, on one side of this beaker, we've got 5 grams of sugar, which has been dissolved in 10 cubic meters of water. And on this other side, which is the right side, we've got 10 grams of sugar, which has been dissolved in the same amount of water. So if you look at the two sides, left side and the right side, you will agree with me that on the right side, we've got more sugar than on the left side, meaning the right side is highly concentrated than the left side. The left side, it is less concentrated. The right side is highly concentrated. How do I know? On the left side, we've got 5 grams of sugar. On the right side, we've got 10 grams of sugar. Meaning, on the right side, we've got more sugar than on the right. On the right side, we've got more sugar than on the left side. Meaning, the right side is highly concentrated with sugar than the left side. So what will happen here is that water will move from the left side going to the right side, because osmosis is the movement of water molecules from a region of high water potential to a region of low water potential. For the fact that on the left side we've got less sugar than on the right side, that simply means on the left side we've got more water molecules compared to the right side. Therefore, water molecules are going to move from the left side where there's high water potential to the left side where there's low water potential. Are you following what I'm saying? Anyone who has understood what I've explained? If you've understood that explanation, let me know. So what I'm saying is the left side, which has got 5 grams of sugar, it has got high water potential than the right side, which has got 10 grams of sugar. Because if you were to test the two, they're going to say, it has got a lot of sugar. iyi amene achokera ku left sugar si ambiri. The one which is from the left side, it is not highly concentrated with sugar. There's more of water than the one which is on the right side. So meaning the one which is on the left side has got high water potential than the one on the right side. That will cause water molecules now to move from where they are highly concentrated, which is on the left side, to where they are less concentrated, which is on the right side. Are you seeing what I'm talking about? Are you able to picture it? So that will cause water molecules, right, to move from where they are highly concentrated to where they are less concentrated. So what do you think is the answer? Okay. So when you look at what we have here, my excellent students, for those that didn't understand my explanation, okay, water will move from a region of high water potential, okay, which is a lower solute concentration region, to the region of to the region of low water potential, which is a region of higher solute concentration. So the left side has got 5 grams of sugar dissolved in water, okay, while the right side has got what? 10 grams of sugar dissolved in water. This means the right side has a higher concentration of sugar than the left side. So water will move from the left side, okay, where there's higher water potential, to the right side where there's lower water. So this movement of water will cause the water level on the left side to decrease and the water level on the right side to increase. Are we clear? So therefore, the answer for question 3 is simply A. Okay. Are we clear? The answer for question 3, it is A, not C. The left, those who are saying C, I'm not understanding anything, sir. Okay. 5 grams of sugar. If you've got 2 cups, in this case, imagine, okay, let me not even introduce cups here. We've got 2 sides of this beaker, which have been divided by this selectively permeable membrane. There's a membrane in between, making this beaker to have 2 sides. On one side, we've got 10 cubic centimeters of water. On the other side, we've got the equal amount of water, which is 10 cubic centimeters of water. On the left side, we've got 5 grams of sugar, which has been dissolved in water. On the right side, we've got 10 grams of sugar, which has been dissolved in the same amount of water. So the left side has got less concentration of sugar than the right side. The right side is highly concentrated with sugar because we've got 10 grams of sugar. So the right side is highly concentrated with sugar. The left side is less concentrated with sugar. Since that's the case, that also means that the left side has got high water potential than the right side, because the left side has got less of a solute than the right side. On the right side, we've got 10 grams. On the left side, we've got 5 grams. Meaning on the left side, we've got high water potential. On the left side, we've got low water potential. And it is true because if right now you were to get 2 cups, in one cup you put 20 spoons of sugar. In the other cup, you put 5 spoons of sugar with water in those 2 cups. When you test the two, you're going to say, in this cup where there are 20 spoons of sugar, it is too sweet. We need to add more water, meaning water potential in that cup is low. And then the cup which has got 5 spoons of sugar, you're going to say, oh, okay, this one, it has got less sugar. It has got more water potential. It has got high water potential. Are you following? And that's the same thing which is happening here. The left side has got higher water potential because there's less of sugar than the right side. The right side has got low water potential because there's too much sugar compared to the left side. So since that's the case, water will move from where it is highly concentrated, which is a region of higher water potential, to where it is less, to where it is, water will move from where it is highly concentrated, which is higher water potential, to where it is less concentrated, which is lower water potential. And that is from the left to the right. So I think with that explanation, you should understand. The answer for question 3 is A. Okay, the diagram shows part of the alimentary canal. The diagram shows part of the alimentary canal. So that is the alimentary canal. We've got A, B, C, D. An enzyme works under the following conditions. An enzyme works under the following conditions. What are the conditions? The food which is being acted upon are polypeptides, temperature 37 degrees Celsius, pH 7. In which labeled region of the alimentary canal is this enzyme found? In which labeled region of the alimentary canal is this enzyme found? There's a diagram here which shows part of the alimentary canal. We've got part A, we've got part B, we've got part C, we've got part D. And then they're saying that an enzyme is working under the following conditions. Number one, this enzyme which is working, it is an enzyme that is breaking down polypeptides. As it is breaking down these polypeptides, the conditions are there is 37 degrees temperature and the pH value is 7. So they are asking us, in which region is this reaction taking place? In other words, where are the polypeptides being broken down by this enzyme? What is the answer for question 4? What is the answer for question 4? Just a minute. Okay. Okay. So let's identify. I've seen a lot of answers. Others are saying A, others are saying B, others are saying D, and I'm going to C. Let's look at the parts. So A is the stomach. Stomach is acidic, meaning that pH value, if you look at the pH value, it is 7, which is neutral. Okay? It is 7, which is what? Neutral. And then B, it is the liver. Then C, they are small intestines. Then D, they are large intestines. So when you look at what's this? A, it is an acidic environment. Why is it an acidic environment? Someone is complaining that they can't see. So if you are watching this video right now, make sure that as you are watching, the quality of the video is high for you to be able to see what is on the screen. Make sure that the quality of this video is high. Okay, make sure that you do that. So there's a camera gear. When you tap on the screen, you're going to see a gear icon on your top right hand. Tap on it, then you're going to see quality. Just tap on quality and then go on advanced, then increase the quality to 720 pixels for you to be able to see clearly. Okay, so now as I was saying, A is the stomach, right? And the stomach is an acidic environment. C, they are small intestines. Small intestines. D, they are large intestines. Now, when you look at large intestines, what are the functions of large intestines, if I may ask? Anyone in the comment section to comment, what are the functions of large intestines? We've identified D to be large intestines, C to be small intestines, A, that's the stomach, B, that's the liver. So what are the functions, or what are the functions? What are the functions of large intestines? What are the functions of large intestines? Anyway, to just not for us not to waste a lot of time, let me just tell you the function. So the function of large intestines is that one, that's where water is absorbed, so they are important for the absorption of water. Two, that's where wastes are stored. Okay, storage of wastes. Okay, so if you look at the two functions that I have mentioned, none of the functions that I've mentioned states that that's where polypeptides are broken down. No, that's not the case. In the large intestines, polypeptides are not broken down in the large intestines. So D is not part of our answer because polypeptides are not broken down in the large intestines. When you look at B, B is the liver. The liver has got many functions. The liver has got a lot of functions. When you look at the functions of the liver, now, number one, destruction of old red blood cells, deamination of excess amino acids, detoxification of poisons. You're going to look at the manufacturing of red blood cells in babies. The other function of the liver is the storage of vitamins. None of the functions that I have mentioned for the liver, which is B, none of the functions concern breaking down of polypeptides. When you look at A, yes, proteins are broken down in the stomach, but the stomach is an acidic environment. But when you look at the pH value there, it is 7, which is slightly alkaline. When you look at C, it is slightly alkaline. It is alkaline, okay? And when you look at the pH value is close to alkaline. And in the small intestines, polypeptides are also broken down, okay? So the answer for question 4 is C. I don't know if you've understood why C is the answer. Question 4, the answer is C. It is not A. Why is it not A? Because the stomach, which is A, it is an acidic medium. It is an acidic environment. pH value for acidic in the stomach, it is, between 2, 3, 2, 3, 4, 2, 3, 4. That's the pH value in the stomach. So that does not qualify to be our answer. So C is our answer. It cannot be B because the liver is not a site where polypeptides are broken down. It cannot be D because when you look at the function of D, it absorbs water. It carries out the absorption of water, not the breaking down of polypeptides. So it cannot be D. So let me say it again. A is not our answer because one, it is an acidic environment, meaning the pH value of A is below 7. B, it cannot be our answer because B is the liver, and the liver does not break down polypeptides. It doesn't carry out that function. So B cannot be the answer. C is our answer because they are small intestines, and the pH value matches with that of small intestines. And then in the small intestines, polypeptides are broken down. D cannot be our answer because the function of D, which are the large intestines, is that they are responsible for the absorption of water. So D cannot be our answer. Therefore, the answer for question 4 is C. Question 5. Which graph shows the effect of increasing temperature on the rate of photosynthesis? Which graph shows the effect of increasing temperature on the rate of photosynthesis? So we've got A, we've got B, we've got C, we've got D. When you look at the 4 graphs that we have, which one shows the effect of photosynthesis, the effect of increasing temperature on the rate of photosynthesis? What is the answer for question 5? Five, others are saying A, others are saying B. My students, what is the answer? Mm-hmm. What is the answer? Okay, so this one is quite easy because it should be easy for you to identify the graph for temperature. So we know that when you are increasing temperature, you're also increasing the rate of um, an enzyme, because when you look at photosynthesis is a reaction which is also influenced by enzymes. Enzymes are involved in the process of photosynthesis. Okay, so when you're increasing the temperature, you're also increasing the rate at which the enzymes are acting. So as you're increasing the temperature, even the activity of the enzymes will be increasing, causing the increase in the rate of photosynthesis. Are you following? When you're increasing the temperature, that will affect enzyme activity, meaning the activity of the enzymes will also be increasing because photosynthesis is also influenced by enzymes. Okay, so as you increase the rate of temperature, as you increase temperature, you're also increasing the rate at which enzymes are acting, and therefore which are also leading to the increase in the rate of photosynthesis. Now, when this temperature is increased beyond the optimum temperature for the enzymes that are influencing the process of respiration, then these enzymes will be denatured. That will cause a decrease in the rate of photosynthesis. Let me say that again. When you look at the process of photosynthesis, it is a reaction which involves enzymes, meaning enzymes are participating, okay? Enzymes are participating in the process of photosynthesis by speeding the reaction of photosynthesis. Okay, so how are enzymes affected by temperature? When you increase the temperature, you increase the activity of the enzymes until the optimum temperature. Once you reach the optimum temperature and then you continue increasing the temperature, once the temperature goes beyond the optimum temperature for the enzymes will be denatured, meaning they'll be destroyed. And when they are destroyed, they will no longer carry out that catalytic function, leading to a decrease in the reaction. So when you look at what I've explained here, I can even show you something here. Um, where is that? Just a minute. Let me look for that diagram. I don't know why it's blank. I want to show you the diagram. So the answer for this question is D actually. Okay, D. So I want to show you the diagram which explains why the answer is D. Right. So here's the diagram how temperature affects an enzyme catalyzed reaction. So when you look at this diagram, which is here, it is showing us how temperature affects an enzyme catalyzed reaction like photosynthesis. photosynthesis is an enzyme catalyzed reaction. So meaning the enzymes that are catalyzing the process of photosynthesis are affected by temperature. So as you increase the temperature, you're also increasing the rate at which these enzymes are catalyzing that particular reaction. To catalyze simply means to speed up the rate of a reaction. We know that enzymes are catalysts, meaning they speed up the rate of a reaction. So these enzymes, they are affected by temperature. So as you increase the temperature, you increase the rate at which these enzymes are catalyzing the reaction until the optimum temperature. Once you increase the temperature and it goes beyond the optimum temperature, enzymes are denatured, okay, meaning they will lose their catalytic function. It is the same with us human beings. Our optimum temperature is 37 degrees Celsius, right? Approximately 37 degrees Celsius. That's your normal body temperature. Because at that temperature, enzymes in your body are working at their best. Now, when the temperature goes beyond 37 degrees, or it goes, let's say the temperature increases to 40 degrees or 45 degrees, you will find that it will be too hard for the enzymes in your body to continue working, leading to a reduction or a decrease in the rate of the reactions taking place in your body, because now the temperature has exceeded the optimum temperature, which is suitable for the activity of the enzymes in your body. Otherwise, photosynthesis is a catalyzed reaction, meaning it is influenced by enzymes. So as you increase the temperature, you're also increasing the rate of photosynthesis. How is the rate of photosynthesis increasing? Because the rate of the enzymes that are catalyzing the process of photosynthesis are increasing in their activity. Therefore, they are catalyzing the process of reaction at a faster rate due to the increase in temperature. Are we clear? So the answer is D. For question 5, the answer is D. Are we clear? Okay, let's look at question 6. Question 6 reads, the diagram below shows the effect of temperature on the rate of photosynthesis at low and high light intensities. The diagram below shows the effect of temperature on the rate of photosynthesis at low and high light intensities. So we've got rate of photosynthesis as on our y-axis, we've got temperature there, and then we've got this graph, which is which is for high light intensity, and then we've got this graph which is showing low light intensity. So this simply shows us to say when there's high light intensity and the temperature is increasing, that will also increase the rate of photosynthesis. So the rate of photosynthesis will be increasing with increase in temperature and high light intensity. And then this other graph is showing us that in as much as we are increasing the temperature, but if there's low light intensity, the rate of photosynthesis won't increase. Okay, so the question reads, the graphs show that increasing temperature had little effect under low light intensity, while increasing temperature under high light intensity increased the rate of photosynthesis. Let me read that again. The graphs show that increasing temperature had little effect under low light intensity, meaning in as much as we are increasing the temperature from 10 to 20, from 20 to 30, from 10 degrees to 20 degrees, 20 degrees to 30 degrees, as we're increasing the temperature, nothing is happening. The rate of photosynthesis is not increasing. Why? Because there's low light intensity. So there's no increase in the rate of photosynthesis in as much as we are increasing the temperature. That's what this statement is saying. So the graphs show that increasing temperature had little effect under low light intensity. But as we are increasing the temperature and there is highlight intensity, we are observing that even the rate of photosynthesis is increasing. So as long as there's highlight intensity and you're increasing the temperature, what is happening with the rate of photosynthesis? It is also increasing. So the graphs show that increasing temperature had little effect under low light intensity, while increasing temperature under high light intensity increased the rate of photosynthesis. Which of the following could be the possible reason for this? We've got A, low light intensity is not able to stimulate enzymes. B, low light intensity results in stomata closure. C, high light intensity provides less heat for the reaction. D, high light intensity provides enough energy for splitting water molecules. What do you think is the answer? Why is it this? Why is it the case? Why is this the case? Why is this the case? Why is it that under low light intensity, in as much as we are increasing the temperature, the rate of the reaction is not increasing, but under high light intensity, when we're increasing the temperature, even the rate of the reaction is increasing? Why is it like that? Is it A, intensity is not able to stimulate enzymes? Or is it B, low light intensity results in stomata closure? Or is it C, high light intensity provides less heat for the reaction? Or is it D, high light intensity provides enough energy for splitting the water molecules? What is the answer for question 6? Okay, so the answer is D. Okay, the answer is D. Highlight intensity provides enough energy for splitting the water molecules. So yeah, the light intensity helps. It is a major factor in the reaction or in the splitting of water molecules, because water molecules split during light reaction. That is why it's called when it comes to photosynthesis, there are two stages. We've got the light reaction as well as dark reaction. So during the light reaction, water molecules split. Okay, they split into hydrogen and oxygen. Oxygen diffuses out of the plant, while hydrogen proceeds to the next stage of the reaction, which is the dark reaction. So during the light reaction, there is need for light. Okay, so high light intensity provides enough energy to split the water molecules, and splitting of the water molecules occurs in the stage of light reaction. So the answer for what's this? Question 6, it is D. Question 7. The diagram below shows a section of a dicot stem. The diagram below shows a section of a dicot stem. Which of the labeled structures A, B, C, and D is responsible in supporting the stem? So for those that are not familiar with a graph of a dicot stem in this view, maybe I can show you just a minute. I'm thinking of how I can show it to you. Okay, let's do this. Hopefully, I can finish up with this question. All right, so ish my PC is having some issues with network. So currently I'm using my phone. So please let me know if I'm audible. Just trying. Now let me just upload the file that I was using. I'm now trying to upload the file that I was using. Just a minute. Okay. Now I don't know if you'll be able to see clearly because yeah, I'm using the phone. I don't think this is going to work, but let me try to do this. Yeah, I can't share my screen. Ish. Let's go. Are we able to see what is on the screen, my students? Is it clear? Is it clear? Are you able to see? Just a minute. Just a minute. Just give me about 2 minutes. I want to turn on my PC using another battery. Just hold on, don't go anywhere. Just wait. Just give me like 2 minutes.